Today we will solve this problem. The problem is compute A transpose A and eigenvalues and unit vectors for u, v and u. Then we have to check whether AV which is equals to u into summation or not. The given matrix is A 1 1 0 1 minus 1 1. First we compute A transpose into A. A transpose A. Here A transpose is the transpose of the given matrix A, which is 1 1 0 1 minus 1 1, and A is the given matrix 1 1 0 1 minus 1 1. After multiplying these two matrices A transpose and A, we get 2 0 0 3. In the next step, we have to find the eigenvalues for this matrix. To find eigenvalues, we need characteristic equation. Characteristic equation for equation of A transpose into A. That is nothing but A transpose A minus lambda into I, which is equals to 0. This is A transpose into A, which implies A transpose into A minus lambda into I means 2 minus lambda 0 as it is, and 0 3 minus lambda, which is equals to 0. After solving this determinant, we get 2 minus lambda into 3 minus lambda minus 0 into 0 0, which is equals to 0. Therefore, the eigenvalues are lambda equals to gamma. These eigenvalues are we have to arrange these eigenvalues in descending order. Descending order means larger eigenvalues first and smaller eigenvalue second. We have to arrange lambda 1, which is equals to 3, which is larger eigenvalue, and lambda 2, which is equals to 2. In the next step, we have to find the singular values using these eigenvalues. Singular values is sigma 1, which is equals to root of lambda 1. First singular value, which is corresponding to first eigenvalue, which is equals to root of lambda 1 is 3, root 3, and sigma 2, which is equals to root of lambda 2, which is equals to root of lambda 2 is 2. These are singular values. In the next step, we have to find the eigenvector corresponding to these eigenvalues. To find eigenvectors, we need characteristic polynomial. Characteristic polynomial is determinant of A transpose A, my matrix of A transpose into A minus lambda into I into the matrix X containing x1 and x2, x3, so on, which is equals to 0, which implies A transpose A is this 2 0 0 3, and minus lambda into I means 2 minus lambda. Here 2 minus lambda 0 0 3 minus lambda, which is equals into x is nothing but x1 x2 which is equals to the column vector 0, 0. This is the equation 1. Using this equation 1, we substitute lambda value as 3. Then we get for lambda equal to 3, we get eigenvector x1 which is equals to 0 and 1. We already learned how to find the eigenvector corresponding eigenvalue, and similarly for lambda equals to 2, we have the eigenvector x2 which is equals to 1, 0. The next step, we have to find the unit vectors for v and u. Unit vectors for v and u. The matrix V is containing unit vectors v1, v2. The unit vector, how to find unit vectors? Unit vectors using the eigenvectors. v1 is the eigenvector x1 divided by norm of x1. x1 is the eigenvector x1 0, 1, 0, 1, and norm x1 is norm x1 which is equal to square root of sum of squares of each element. Sum of squares of each element 0 square plus 1 square which is equals to 1. Therefore, norm x1 is 1. The v1 vector, the vector v1 is, unit vector v1 is 0 and 1. Similarly, we have to find v2. v2 is x2 divided by norm x2 which is equal to x2 is the column vector 1, 0, 1, 0 divided by norm x2 is root of sum of squares of elements 1 square plus 0 square which is equal to 1 divided by norm x2 is 1. Therefore, the v2 is 1, 0. Using v1 and v2, we construct the matrix V is v1 is 1, 0. The column matrix 0, 1. v1 is 0, 1 and v2 is 1, 0. The column matrix 1, 0. This is the matrix B. Then we have to find the LHS A into V. We have to multiply the given matrix and the matrix B. A into V is 1. A is 1, 1, 0, 1, minus 1, 1. And V is already obtained V matrix 0, 1, 1, 0. After multiplying these two matrices, we get one, 1, 0, 1 minus 1. This is equation number 2. To prove LHS equal to RHS, we have to find U into summation. Here, to find U and summation, we have formula U is the containing unit matrix U1 and U2. U1 is 1 by sigma 1 A into B1. What is sigma 1? Singular value. A is given matrix and V1 is unit matrix. Unit matrix of V1 is equals to 1 by sigma 1 is root 3 and A is given matrix 1 1 1 0 1 1 0 1 minus 1 1 0 1 minus 1 1, and V1 is the column matrix containing 0 and 1. 0 and 1. After multiplying these two matrices, we get the column matrix 1 by root 3, 1 by root 3, 1 by root 3. The U1, unit matrix U1. And for U2, we have formula 1 by sigma 2 into A into V2. Sigma 2 is singular value, second singular value 1 by root 2. A is given matrix 1 1 0 1 minus 1 1, and V2 is the unit vectors of V 1 0 1 0. Therefore, after multiplying these two matrices, we get 1 by root 2 0 minus 1 by root 2. Therefore, using U1 and U2, we construct a matrix U which is equals to U1 and U2. U1 and U2 is U1 is 1 by root 3, 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 1 by root 3. U2 is 1 by root 2, 0 minus 1 by root 2. 1 by root 2, 0 minus 1 by root 2. This is the matrix U. To find a RHS, we need summation, matrix summation. Summation matrix is given by sigma 1, the matrix of sigma 1, 0, 0, sigma 2. Here sigma 1, sigma 2 are the singular values, which is equals to sigma 1 is root 3, 0, 0 into root 2. This is the sigma matrix. Then we have to find U into summation. What is U into summation? U is this matrix containing 1 by root 3, 1 by root 3, 1 by root 3, and second column 1 by root 2, 0 minus 1 by root 2. And the summation matrix, summation is root 3, 0, 0, root 2, which is equals to, after multiplying these two matrices, we get 1, 1, 1, 0, 1 minus. This is the equation number 3. On comparing equation number 2 and 3, the both are equal. The LHS of equation number 2 and 3 are equal. Therefore, we equate the LHS of 2 and 3 equations. Therefore, we get AB which is equals to U into summation.